Welcome back to today's Explainer Super Learners. Have you ever just looked up at the night sky and thought, it's kind of wild how the moon seems to be trapped in this constant cycle of transformation? I mean, one night it's this perfect, glowing round ball just lighting up the whole landscape, and then a few weeks later, it's basically reduced to a tiny glowing banana slice hanging out up there in the stars. So why exactly does our nearest celestial neighbor do this crazy shape-shifting routine? It's literally one of the most magnificent things we can observe right from our own backyards, but it's just so easy to take for granted. Well, today we're going to dive right into the mechanics of this cosmic cycle and decode exactly what is happening above our heads.
Okay, let's dive into this. Is the moon physically changing its shape? Like, is it actually expanding and contracting out there in the vacuum of space? Or, as some old myths and fairy tales playfully suggested, are there little space mice up there just taking nibbles out of it as the month goes on? Because let's be honest, it really does look like a massive chunk is just missing on certain nights. But the reality? It's actually a lot more fascinating than hungry space mice. The changing shapes we see are completely an optical illusion created by celestial mechanics. We're going to explore the phases of the moon to figure out the exact geometry and science going on, and spoiler alert, the moon itself isn't changing at all.
Now, what's really interesting about this slide is that the secret behind all this shape-shifting is that the moon doesn't change its physical structure whatsoever. No shape-shifting, no space mice. It is always a solid, spherical rock floating in orbit. The twist, though? The moon emits exactly zero light of its own. None. It actually acts like a giant space mirror. And here's a pretty fascinating fact. The moon's surface is actually the color of dark, worn asphalt. It really doesn't reflect light that well at all, yet it looks incredibly bright to us simply because it's contrasted against the pitch-black void of space. The sun shines brilliantly onto this dark rock, and that light bounces off so we can see it. So depending on where the moon is in its orbit, we just get to see different parts of its lit-up side as it dances around our planet.
Step right up, because since the moon is constantly orbiting the Earth, it catches the sun's light from different, ever-shifting angles. It puts on what we can playfully think of as a cosmic dress-up show. It's presenting an entirely different face, or costume, to us, depending on its exact mathematical position in space. The light slowly creeps across the lunar surface, changing the shadow's geometry night after night. And by tracking this light, we can accurately measure time, predict tides, and just understand this intricate dance between the Earth, the moon, and the sun. So are you ready? Let's count down the moon's favorite costumes together and break down the exact sequence of this celestial cycle.
Let's move to and see how this builds. We've got 5 main steps in the first half of the show. First is the new moon, then the waxing crescent, the first quarter, the waxing gibbous, and finally, the full moon. Now that word waxing is just an old term that means to grow or increase. So this sequence builds from complete darkness, step by step, until the moon is entirely illuminated. Each step is just a distinct shift in our viewing angle from Earth. Let's break down exactly what's happening up there in the sky at each of these visual milestones.
We begin with the new moon, or what I like to call the ninja phase, because it is super stealthy. In this phase, the moon is hiding right between the Earth and the sun. Now, don't get me wrong, the sun is still illuminating the moon perfectly. It never stops shining. But it's lighting up the far side, the side facing completely away from us. So for those of us down here on Earth, the side facing us is in complete shadow. It's basically playing a massive game of hide and seek, blending perfectly into the dark night sky so we can barely even see it. It's up there, doing its thing, just hidden like a ninja in its own shadow.
But hey, that stealth mode doesn't last very long. As the moon moves just a few degrees further along its orbit around Earth over the next couple of days, our perspective totally shifts. Slowly, this tiny sliver of illuminated rock becomes visible on the right-hand edge. This is the waxing crescent. Remember, waxing means growing. And this little crescent is the very first sign that visible light is coming back to our night sky. Honestly, it looks just like a glowing, smiling banana slice up there. The line separating the light side from the dark side is called the terminator line. And if you watch over the next few nights, you can literally see this terminator line creeping steadily right across the craters and seas of the moon.
Next up comes a phase with kind of a confusing name, the first quarter. Visually, the moon looks like it's been cut right down the middle, right? It's half completely dark and half glowing like a bright orange slice in the sky. So you're probably wondering, why do astronomers call it a quarter when it so obviously looks like a half? Well, the name actually has nothing to do with the amount of light we see. It's all about the moon's journey. At this exact moment, the moon has completed exactly 1/4 of its orbit around the Earth, starting from that sneaky new moon phase. The light and dark are perfectly balanced from where we're standing, but the moon itself is only a quarter of the way through its monthly road trip. Moving right along, we arrive at the waxing gibbous phase. Now, if you've ever wondered where the word gibbous comes from, it actually comes from an old Latin word meaning humpbacked or swollen, and that perfectly describes what's going on. The illuminated part is getting bigger and plumper, swelling way past the halfway mark, kind of like a fluffy white marshmallow puffing up in the sky. That terminator line keeps pushing closer and closer to the far edge. The moon is almost fully lit at this point, acting like a giant cosmic sponge just soaking up all that sunlight as it gets ready for the grand finale of the waxing sequence.
And then, boom, we reach the absolute peak of the cycle, the full moon. At this point, the Earth is lined up directly between the sun and the moon. Because of this straight line alignment, the entire Earth-facing side of the moon is just bathed in complete uninterrupted sunlight. The shadows totally vanish, that terminator line is pushed right off the edge, and the whole face is lit up. The moon shines so brilliantly it's basically a giant glowing disco ball totally dominating the night sky party. It gets so incredibly bright that it can even cast shadows down here on the ground, and totally wash out the fainter stars around it.
And this brilliantly illustrates the beautiful, perfectly symmetrical two-part rhythm of the lunar cycle. We just went through all the waxing phases, right? The moon growing bigger and building up to that huge disco party. But after the full moon peaks, the orbital mechanics take over and the whole show literally goes backward. This is where we enter the waning phases. Just like waxing means to grow, waning is basically a magic shrinking act. The shadow starts creeping back over the moon's face from the exact opposite side. We watch it shrink from that glowing discosphere back to a puffy gibbous, down to a half moon, then a little crescent, until it vanishes completely back into our stealthy ninja new moon.
So the crucial point is that this entire magical progression, from the new moon all the way up to the full moon, and then fading back to complete ninja darkness again, takes exactly one whole month to complete. Technically about 29.5 days. It's just an incredibly reliable rhythmic cycle. Actually, it's so reliable that our entire concept of a month on our calendars was originally based on this exact lunar cycle. If you look at the linguistics, the words moon and month actually come from the exact same ancient root word. Every single month, without fail, this orbital dance repeats itself flawlessly, keeping our planet company as we travel together around the sun.
So tonight I have a challenge for you. Step outside with a grown-up, look up at the sky, and see if you can figure out exactly what costume the moon is wearing right now. Check which side the light is on, look for that terminator line, and see if you can tell if it's currently waxing or waning. But as you're out there looking up at that glowing rock, I want you to think about one final wild fact. Because the moon's rotation speed is perfectly synced up with its orbit around Earth, something scientists call tidal locking, we only ever see this one side of the moon. We never ever get to see the far side of the moon from our backyards. What kind of mysteries does the dark side hold? Well, that is an explainer for another time. Thanks for hanging out with us, and keep looking up.